final speaker today is Dave Amor from Ultra Maritime. He is a Senior FPGA Engineer, specialising in the development of safety-critical motor controllers and power converters for military applications. He has championed the adoption of continuous integration, CI, practices with MathWorks tools, enhancing the efficiency and reliability of FPGA development. He is an advocate for agile methodologies, particularly Scrum, and Dave actively promotes collaboration and continuous improvement within the team. And the title of his talk is Integration of Atlassian Bamboo with MathWorks Tools for FPGA Development.
Thank you.
Thanks, Dave.
My name's Dave. I'm from Ultra Maritime in Rugeley, which is in Staffordshire. Being the most landlocked part of the country, we specialise in maritime applications. That sort of stuff. So I'm part of a team of about 25 engineers and about half permanent, about half contractors, and we're still recruiting. Today I'm going to be talking about integration of Atlassian Bamboo, which is a continuous integration program. Which, spoiler alert, it's basically, if you've got a batch file, it just runs those batch files for you in the sequence. So it's nothing flashy, but it's the philosophy behind it and how it integrates with MathWorks and different tools that's interesting. So we're still fairly early in our adoption of Bamboo and of Scrum. But this presentation is full of some stuff that I'd like to have known when I was starting to learn about Bamboo. So the agenda today, I'm going to cover the process and workflow, a little touch on Agile Scrum, which gives you a bit of background why I want to use Bamboo, some of the enabling technologies and tools that we use, and then the core of it is Jira, which is another product from Atlassian, and then finally the continuous integration, especially the stuff with MathWorks products. So a little bit about our workflow. So like you say, we work on high reliability, power dense systems, very safety critical stuff, and we work to several military standards and safety standards like 61508 and DOT 54 sort of what we found is that you can de-risk the core algorithms of control algorithms and filters and the complex things that we have the PhD systems engineers putting together. We can de-risk those as soon as we've had requirements from the customer fairly early on at the systems level. So we can, within a matter of months of receiving requirements, we can try and predict what sort of issues we're going to have later before we've actually started doing the low-level design, and also see any of the emergent behaviour, the interaction between the different demands that come on the design. So first of all, if we compare a traditional process, which would be handwritten requirements or received requirements that then is documented and is captured in one place that's fairly universal, against model-based design, which we use Simulink and MATLAB for that. In a traditional process, it's fairly easy to overlook gaps in the requirements because it's a set of handwritten requirements, and you lose that resolution of or that clarity of what they mean when they're asking for a requirement. When a requirement's written there, it's not easy to really understand what's behind it unless you've had detailed discussions with the customer. What we do is we then translate those written requirements into a set of models for the system engineer does. It makes it a lot easier to tell if it's correct earlier rather than having to wait until you've got quite far down the development process. The whole aim is to actually try and catch bugs earlier, where it's cheaper to fix them. So the process and the workflow, we would one of the strengths is managing how it manages those requirements in model-based design. By capturing the requirements as a model and verifying them through simulation within Simulink, we can break down the complex systems into functional blocks. And then this structured approach lets us figure out any of the contradictions or even undefined behaviours that the customer may not have considered. And we can actually, in the past, we've gone back to a customer and said, is this really what you meant? Because this conflicts, or this isn't, this doesn't quite make sense. Ideally, the customer would would provide a model of what they want the behavior to be. But I mean, one day that's never happened yet. And then once you've got a system level model with your plant model and all that sort of stuff, then you can check with the customer that it's exactly what they want before you've even started making any code or synthesizing anything. So very quickly, as we move from this high level system level design down to the FPGA development, the model will evolve in granularity and detail as it progresses down. So you can create independent test benches as well at the system level, and then hopefully when we've got our RTL structural synthesizable code, we can then reintroduce that back up to the original test benches that are linking it back to the requirements. So it's horses for courses. So you've got some blocks that warrant having Simulink, things like control algorithms and complex algorithms. You know what I'm trying to say. But in general, you can use a hybrid. So you don't have to just use Simulink. You can use conventional VHDL. We use VHDL. So for depending on the sort of interface that you work through. So the process is, or the steps in the process are, we'll go from a systems design. So the systems engineer will say this is what I want. We'll then go through the trade-offs. It's a bit washed out there, but basically, rather than it being analog and floating point, we'll make a decision on the resolution of the signals and how fast things need to happen and all that sort of stuff. And then we'll try and create an equivalent RTL model. There's lots of negotiation between the FPGA engineers and the systems engineers to say, you've made this like instantaneously. Do you need it to be instantaneously, or is it, if it takes a few milliseconds, is that okay? And those sort of negotiations, we can have that in a common language as well. So everyone's using Simulink, so everyone's comfortable. And then the tool itself, Simulink, actually generates our RTL, which most of the time you can understand what it's doing, but a lot of the time it's not nice. But we kind of don't care if the VHDL is not nice. It works and it fits the customer requirements. The other things that we have interfaces or specific things that are better suited for VHDL, then we'll hand code those a bit nicer. So yeah, the trade-off, you go through things like your normal area and delay and things like multiplexing your adders and multipliers rather than having several of them. If you figure out you only need one or two things, whereas if you were to use the autocoder straight from the system design into synthesizable RTL or a DSP or something like that, it would be very inefficient. It wouldn't optimize it in the same way that a human would make those design decisions. And the other advantage is, when the systems engineers are doing their models, the same input model can be used in a different target device. So we've got a DSP process where we have, they will target a DSP to do the proving out of all the power electronics that go along with it. And then when they translate it to an FPGA for certification, we've got a proven behavior in a system level model that is we've got a lot of confidence that it's correct. This is this is the sort of test bench we have for a Simulink block. So we'll have the actual DUT, a set of stimulus and checkers, and then it says co-simulation there. That's essentially a MathWorks term to say that it's this foreign language interface to a simulator. So you can have your generated VHDL still be tested and stimulated against your original model and your reference model. So here we've actually got systems engineers model in the reference, which is floating point, and it can be any sort of construct. And then you've got the DUT, which is our synthesizable RTL sort of constructs. So the next part, that's a bit of an overflow of why we're using Simulink. Half the issue is why bother using Simulink. But so yeah, when the system engineers finish their dissemination of the requirements and all the algorithms have been ironed out, and it's been apportioned to different parts of the system, we start our FPGA flow. one of the philosophies that drives the adoption of Bamboo is continuous integration and these the prospect of being able to have smaller iterations quicker earlier on in the development process where you can do these experiments. Because we work in a fairly safety critical environment where everyone likes to have a lot of certainty, having these smaller experimental tests, short-term tests to try and iron out issues, it doesn't really match up with the industry that I'm in, military and that sort of stuff. They don't like playing with stuff. They like to be very, very certain. So we've adopted the Scrum process. It's about iterative process, collaboration, and it's all about the customer centricity. So it's more about having more feedback to the customer, and that might be an internal customer. So it might be the systems engineer themselves that would be the customer we'd be talking to make sure that they're happy with it. So Scrum, like I say, promotes these frequent changes in its experimentation, and this contrasts with the traditional safe and steady plodding attitude. So we try and manage this chaos by carefully selecting the tasks during the sprint planning session. And these are tasks of bite-sized iterations that can be tracked against a Jira release. So Jira is the Atlassian software that links in with Bamboo. So trying to track everything you want to have in the next revision of your FPGA. If you tried to do that manually, it would be error prone. It'd be very time consuming. It wouldn't have the sort of transparency with the customer, so they wouldn't know what you're working on next. It just wouldn't be effective for your project management. So Atlassian allows us to track bugs and plan out what the next set of work is going to be, the new features they're going to be working on. So a little bit, again, this is skirting around the Bamboo, but it's getting there. It's getting there. The main thing is with Jira, what it gives us, the benefits that it gives us, is allows us to focus on the priorities and not be distracted by things. If you didn't have a list of to-dos for that period of time, it allows us to have clear release planning as well. So we know what's in each release, and there's a bit of clarity to it. Got accountability, so you can have a definition of done. So if you can give somebody else a task to do while you're working on something else, you've got more confidence that it's going to be as you intended it to be. You've got the efficient bug fixing, so you've got tracking of bugs in one place and your implementation task in one place. And then again, the stakeholder transparency. There's other things that we use it for. We use it for the continuous improvement stuff, the retrospectives and that sort of stuff. And then also we've got team alignment, so everybody knows what we're doing for that sprint and what's the priority to work on. Some of the other tools, obviously you need a version control system. That's fairly fundamental. We have the MathWorks parallel server toolbox. So we have a farm of processor core workers that you can give test benches to, and it will just run away and process those. And then we also use things like BUnit and sorry, Aspen, we use OSVBN as well. And then again, obviously, I've mentioned the Jira task system, NAS drives to store all this stuff as it comes out. Right, getting there, close. Hold on. So yeah, continuous integration. It prevents code rot. So when you've got your test benches delivered and in a process, you would need to be careful not to never run it again. If it's passed once and then you think, oh, it's going to be okay, you make changes, and nobody ever goes, oh, I'm going to run some old tests that have been sitting on the shelf for ages. So continuous integration allows it automates the regression test running of previous tests. So to adopt, when we started on the adoption of Bamboo, two of my colleagues, James Head-Rapson and Andrew Stevenson, they did all the heavy lifting. They investigated all the different methods and all the different ways of using it and all the different techniques, and all the mistakes that they made, I've very much so learned from. So big nod to them. So the Pareto principle, the 80-20 principle of the amount of work left to do, and it is 20% of the work left to do, but that's 80% of the effort. So the methodical system and upfront design work has been set in stone, and we don't want to break it because those test benches prove that we've got correct behaviour. However, we've still got a lot of implementation decisions that were made with the best information that we had at the time that we made it. So yeah, so and that information can evolve as you understand more stuff, as you get further and further into detail. This can be done with manual regression testing, but who does it, and what do you do with that person's work when they're running regression tests? So you having an engineer off their job to do 500 tests of previous testers, it's not. And also engineers, they have a tendency to go, oh, that's only a little change, it's not going to break anything. So having that sort of tendency, and everyone thinks, oh, it's never going to break it, and then it does. So now we've got this house of cards where we've got lots of different enabling things that you need to have in place before you start using this method. Things like you've got to script your build processes and your test benches. Everything has to be run from script. You have to have a version control system. That's fairly fundamental. You have to have test benches for one. You have to have rigorous reviews and sprint plans and iterations, and be really structured with what work you're going to do, so that you can start using this sort of technology. So start to get there now. It's time.
Yeah, you're good, but 15 minutes.
Cool. So yeah, the code is generated by Simulink or hand coded via HDL, and then it's authored by several team members based on different tasks. And again, you don't know if somebody else has added 3 new tests and somebody else has modified a bit of code to something. You can talk to each other. We do talk to each other, and 99% of the time it's fine. You know, we catch everything, but there's an occasion where you might find someone's added a test or modified a test, or if you change versions of software, that does the test still work, and that sort of stuff. So you author your code, and you commit that into some sort of source control. So we use Subversion at the moment. We've investigated Git, we're looking at it, but I can't really see a major advantage at the moment for the way we work. So you put that into source control, and then Bamboo sits on a server, and it says, has there been any changes to the source code, and do we want to run it? You can configure when it runs, so when it triggers. So you can either have it based on a time scale, so once a night or once a week, or depending on what scale of work you have to do, you can, or just manually. So you do your changes and then choose to manually run it when you think it's warranted. So some of our tests can take quite a long time to run. You know, a few weeks for a regression test is not unheard of. So you don't want to do that every night. It's gonna, you know, you wouldn't find your feedback loop quick enough. But you can do a subset of them. So you have to be pragmatic in what you choose to value for your regression. And then, yeah, and the hybrids as well. So if you want to have some of the modules be tested every time there's a change, or just manually when you because it's a larger system or something like that. And then when it's finished, it can get you, it emails you, whether it's passed or failed. You can configure that if you want it emailed you, or a message, or you can just have it left on the Bamboo server. And then when you go into there, if one of the tests has failed, it integrates really nicely with Jira. You just click a button, and it will then create a link between your Jira task. So you can say this Jira task was, and this regression test failed, and then the implementer, when they try and do a fix, they can then identify which test failed, rerun it then manually on their own system to make sure it's still passing, without having to then go through the entire process of doing a full regression. They just go, right, that one test that failed now is passing on my local machine. I'll put that on, and then when the results come back, you've got your confidence that all of the other tests are still working well. And also when you commit to your version control system, you can link it into the task of Jira. So you've got this ability to say, then these are the bugs that were fixed in this release. These are the new features that are in this release. And this is all fairly common practice from, I mean, the mid 2000s in the software world, but I don't know. I get the impression that this isn't exactly widely adopted in the FPGA environment. It doesn't seem to be anyway. And certainly for MathWorks, the they've got some fantastic support for their continuous integration server. So all the different sort of manufacturers that I've talked about Bamboo, but there are lots of different manufacturers. Jenkins is a popular one. And it goes from being a service to a server. You can have them all in the cloud. So this phase here, the execute the plan, to actually get your Simulink models running through the Bamboo, you can use a toolbox called the Simulink Tester. They're very good at selling the toolboxes, MathWorks are. So they have this Simulink test, which contains this test manager. And you've got your list of tests on the left-hand side, and it gives you a nice toolbox, a breakdown of the report of how many tests have passed and failed. You can link in written requirements if you want to as well, so you can get a breakdown of which tests, or if you change a requirement, it will then tell you which requirements have changed, and then you can rerun the subset of tests just for that set of requirements that have changed, if that happens. Or if a test fails, you can say which requirement it links back to. So, but that's a whole other discussion. But basically, you can then, through the plugin for Bamboo, you can get it to output this X units output. So that then links back into the Bamboo interface that is interpretable. So you never need to see as an implementer, I never need to see the test benches running anymore. I just get it's passed all of the tests or not. Yeah, there's something else I want to say. So yeah, MathWorks have also, they've got run MATLAB commands. So because we generate the VHDL from the Simulink models, you can do all of that within Bamboo. So you can get you commit your model, and then it generates the VHDL, it runs all the test benches, and goes through all the synthesis steps as well. So you can go right from your world right the way through, and you can get it to do all of your libero builds and your synthesis warnings. You can gather your warnings together. You can get it to parse the results to make sure there are no new synthesis warnings or anything like that. So, and then anything that can run from a batch script, you can run through Bamboo. So that's the crux of it. That's the justification behind it, and this is the way that the plan works. You can have several steps running at the same time. So whilst you're waiting for your Simulink tests to pass, you can be building the bit stream and also be running the VHDL code generation. And if somebody, so I'm an implementer for the majority of my time, but on our team, everyone does everything. So if an implementer swans off to a seminar one day and somebody else needs to make a change, but they're not completely au fait with how you run your build process, all of this is universal. So anybody on the team can make a change at a higher level and then have confidence that it's going to go through all the tests and finish it through. So that's my presentation. The takeaway is that it's better to have lots of small changes, but in a structured way, so not so chaotic. You've got to be confident that you're not breaking anything from earlier on with your smaller experiments. So yeah, thank you so much. Any questions?
We'll take questions from the audience first. Yeah, do you want?
Thank you for the presentation. Thank you.
Nice to see you. Yeah. Most of what you're talking about there, certainly when you're referring to design and the test, is that FPGA levels primarily? You mentioned obviously modular level as well through CI, but is the bulk of the abstraction work that you do here at the FPGA device level?
Do you just want to repeat the question?
Yeah, so he's asking about the level of abstraction from for the FPGA, if it's just module level or at top level. Everything. So you've got individual component testing and lower level lines of code you can test, or you can have module tests. And again, as I was saying, you can configure how rigorous you want it to be. So if you've got one module that you've made a change to, you probably want to do some regression testing at the top level, but because that takes a long time, you might not always run that plan unless you've had a few changes. So you might say, I want to have my top level tests manually run, but the module level tests on every change, and Bamboo allows for that as well. So yeah, thank you.
There's a couple of online questions. There's another question in the audience. Yeah, sorry, go ahead, John.
Thank you for the presentation. Agile CI, yeah, big topic of interest around FPGA. I probably might be able to talk to you afterwards.
Okay.
Some details, but how do you find your sprints with FPGA development? Because I know for a lot of people that whole aspect of doing sprint planning with FPGA and saying you're going to complete this within your sprint just doesn't work with FPGA design.
Yeah.
Thoughts? Comments?
Do you want to just quickly?
The question was about the approach for Scrum sprint planning and trying to ensure that you adhere to the tasks that have been assigned for that sprint period. So yeah, it is awkward. It's not quite the same as software. It isn't quite the same as software. There are distinct differences, but you can draw parallels, and it's the mindset and the methodology behind it. It's about having short-term feedback as quickly as possible, and having structured approaches without distractions, and having clearer priority of tasks, and also team working. So in the past, you might find that somebody will dynamically choose to concentrate on something, which and you have emergent bugs coming through. So basically our approach is we underutilize in the sprint planning so that we can accommodate for emergent work. So we still have a backlog, so you can pull from it whenever you need to. But the main gist is you have enough work to get you through 50 to 80% of the time you've got, and then there are emergent things that can come through that will fill up that time. But if you run out of work, there's always somebody else to help with, or somebody else that you that can jump onto some of your tasks if you're going over. So there's a lot more collaboration needed for it.
What's your typical length of sprint?
So we're doing 4-week sprints. Yeah.
Okay.
Yeah, in 4-week sprints. Yeah.
I lost more later.
Yeah. Okay.
Any more? So there are a couple online, and we've got time, so I'll just ask these couple online. In MATLAB automated code generation, do you have any concerns about lack of obvious low-level protection, such as overflow protection?
So when you're making the RTL, when you're actually using Simulink, you don't change your mindset with the way you're implementing it. You're just writing the code in a different language. The philosophy behind it, things like overflows and things like that. If you wrote code that was sloppy in VHDL, it would have the same issues.
Okay.
But yeah, basically, it's about being rigorous with the way you garbage in, garbage out.
Okay.
Yeah.
Okay, and is there any additional difficulty in certifying auto-generated codes for MATLAB? Have you certified a MATLAB generated HDL under D0254?
The short answer is no. We've not done D0254, but we do adhere to the same sort of techniques and standards. And we have auditors that come in, and we've never had issues with the generated code. But basically, all of the techniques that we have are predicated on not trusting anything. So we don't even trust the synthesizer. We will do shadow synthesis. We don't trust any of the tools. Everything is duplicated. Everything is checked twice.
Those tools are certified.
Yes,
Yeah.
well, I would have hoped so.
Yeah.
That's above my pay grade. That.
Okay, well, that's a good place to finish. Thank you very much today.
Another one?
Oh no, sorry. Well, John's back
John.
in.
Just related to
Yeah.
that, I saw you do formal leg.
Yes.
Are you able to share how you do your formal leg?
I think.
I don't work with one spin anymore.
Oh, don't you?
Company now.
One spin.
So yeah.
One thing you answer.
Is that your question? Was it?
Other tools
Okay.
are available.
Yeah. Yeah. Was that your question? Yeah.
Yeah.
Okay.
Okay.
Yeah.
Yeah. Any reason why you picked bamboo?
Well, it's the question was about why did you choose bamboo? Yeah, there are lots of other things. Essentially, it was because we've got Jira and Bamboo. We've got a software team that's already using it. We've got management were happy for us to use Bamboo and kind of said we'd rather not have another tool set floated around. But it really does integrate well into Jira, which it's if I get a day without looking at Jira, I'll be shocked. So it's very much the common interface for everything, really.
And your requirements or link in that or?
So we use RMSys, which is another Jira plugin. It's similar to Confluence. It's another tab that you can go into, but yeah, we do trace requirements through RMSys. Okay, thank you.
Okay, thanks,
Lovely.
Dave.
Thank you very much.
1 minute until lunch. I'll just quickly say I'll thank you especially to the Rolls-Royce and to Dave who stepped in and my train was delayed. So thank you very much, Dave. Thank you very much to Disha as well. Probably a lot of you communicate with Disha. She sat online making sure everything goes smoothly as well. So thank you to Disha as well. The presentations, both the PDFs go up very quickly. Recordings take about a week. Will be available to you. We'll make sure they're available. And we've got your email, so we'll let you know. Same for the people online as well. You'll receive all the slides and recordings that be made available. If so, only future topics. We run 4 FPGA frontrunner events a year now, and they're fairly well defined what we do. The next one will be at Thales, and that will be on safety and security. And then we have Renishaw in the audience, but hopefully next year Q1 will be at Renishaw back on AI and ML, I think. And we had that this year, and that went quite well. So I'm looking at Pete from Renishaw to get confirmation that we're there. There you are. You heard it hot off the press. But we do have these 4 a year, and I think we're trying to we get into a regular pattern. And we're seeing more and more people online and more people physically as well. So that's good news. And as I mentioned there, safety and security at Tyler's date TBD. But it will be Q4. So we're trying to move them to every quarter as well, getting that back. Okay. And final thank you. And obviously Rolls-Royce as well for hosting, Dave for stepping in and for the food and drink. And I think it's all outside. If you are on the tour, kicks off at 2 o'clock.
2 o'clock, yes.
Dave's got your name. So we've got your names, and if you're not on the list, you won't get in because it's security. Otherwise, thank you very much for coming. Enjoy your lunch and enjoy your travel home.
Thank you, Mike. Thank you, everyone.
Thanks, mate.
Cheers. Cheers, thank you.
Thank you to David.
Right, have some drink, huh? I'm assuming.
I'm staying there for Sunday.